Welcome to EDU World Space.
So we want to find the density of seawater given we have a depth of 5.4 kilometers. So we can say that the change in volume divided by the original volume would be equal to the negative change in pressure divided by B, the bulk modulus. So we can say that the change in pressure would be equal to the density times the gravity, the acceleration due to gravity rather, times the change in height, or in this case, the depth. And we can say that the mass is going to be equal to the density times the volume, or we can say that the original density times the original volume. So this is simply saying that the mass of any unit mass of water is going to be the same whether you're at the surface of the sea or, again, 5.4 kilometers beneath the surface. All this is saying is that the mass is going to be constant. So using this relationship, we can say that the density at that particular depth is going to be equal to the density at the surface times the volume of the surface divided by the volume at the surface plus the change in volume as you descended down 5.4 kilometers. This is going to be equal to the density at the surface times the volume at the surface divided by the volume of the surface plus the negative VO, rather plus negative volume of the surface times the change in pressure divided by the bulk modulus. So at this point, this is going to be equal to the density at the surface divided by 1 minus the density at the surface times the acceleration due to gravity times h, the depth, divided by b, the bulk modulus. And at this point, we can actually solve. So p, the density at 5.4 kilometers, will be equal to 1,025 kilograms per cubic meter. This would be the density at the surface. And then this would be divided by 1 minus 1025 kilograms per cubic meter times 9.8 meters per second squared times 55.4 kilometers, or 5.4 times 10 to the third meters. And then this is all going to be divided by the bulk modulus of 2.0 times 10 to the ninth newtons per meter squared. And so the density is going to be equal to 1,054 kilograms per cubic meter. And again, this would be at 5.4 kilometers, or 5,400 meters. We want to find the ratio. So the density divided by the density at the surface would be equal to 1054 divided by 1025, and this is equaling 1.028. Therefore, the density, it's going to be 2.8% more dense. The density of water will increase by 2.8% at a depth equaling 5,400 meters. So this would be your second part of the answer. That is the end of the solution. Thank you for watching.